Hi there, my name's Mark Payne. It's great to be back in the warehouse here at SFL now that lockdown has eased somewhat, and I'm here stood in Microphone Alley. We've got wired mics on the left and radio mic racks on the right hand side, and I'm going to be taking you through actually what's in my personal mic kit. Maybe I'll look at some of the expensive stuff, sure, but I'm more interested in the mid-range and the cheaper end of what I use to do live shows and productions for recording and also live events. I want to give you an idea of some of my dirty tricks and cheap stuff that I use to great effect, so that you don't need to spend so much money on your mic rig. So I'm back from SFL, back in the studio here. Let's go through the sections, the first three sections. If you've got experience with microphones and you've been around for a while, then feel free to skip it, because we're going to talk about section one, what is a dynamic microphone versus a condenser microphone. So why would we use one rather than the other? Section two, we'll look at pickup patterns, i.e. what is the difference between an omnidirectional, a cardioid and a hypercardioid. In section three, we'll look at proximity effect. What happens to a microphone when we get closer to it and further away, and how does that lead to how we can use microphone technique. In section four, I've pulled out a couple of trays from my flight cases, and we'll have a look at what's in my own personal mic kit. What have I chosen to use? I've got a kind of concept of I use what I sell and I sell what I use. If you want to know what decisions I've made on microphones, then we'll go through that. And then in section five, I've got a couple of really dirty, cheap secrets on microphones, mics that you might not have heard of before, which are highly cost effective, and little secrets of mine that I'll share with you as well. That's section five. So feel free, if you've really been around for a while and you don't want to listen to the theory of the first three sections, feel free to skip that. Maybe you'll understand a little bit more, or it'll give you a better narrative for things that you already know by intuition. Anyway, stick with me. Let's get going in section one. So dynamic versus condenser microphones. Okay, here I've got a Beta 57. It's a Shure microphone. It's a dynamic microphone. Here I've got a Superlux microphone, which I'll talk about later. It's a condenser microphone. It's a pencil condenser. Okay, so a dynamic microphone is basically a speaker in reverse. What we have inside is we have a diaphragm. It's at the top of this plastic piece here. It's a lightweight diaphragm which is attached to a coil of wire, and that coil of wire sits in a magnet. The magnet will be about in this area here, and when I speak into it, it vibrates the diaphragm, which is attached to the coil, and we move a coil inside a magnetic field. And if you move a coil in a magnetic field, you induce a voltage, and we can use that voltage inside the microphone. It gets balanced by a balancing transformer and then sent to the mixing desk, which obviously is a very small signal, and it needs amplifying within the mixing desk, and then of course then further amplifying in the power amplifier, and then we basically have this in reverse as a speaker. We have a coil which we pass big power into. That moves the coil in a magnetic field, and that then pushes the diaphragm of the speaker, which then creates sound pressure which we hear. So really, a microphone and a speaker, a dynamic microphone and a speaker, are really the same sort of device. So in here there's no electronics. All there is a diaphragm, a moving coil, a magnet, and a balancing transformer. When we talk about a condenser microphone, slightly different. We still have a diaphragm, but now we have really two plates. One is the vibrating diaphragm, and the other one is a substrate plate which forms a capacitor. You probably know that in electronics we draw a capacitor as basically two plates separated by a distance, and the plates have a surface area facing each other, and effectively the capacitance of this electronic device depends on really three things. It depends on the quality or the material of the substrate between the plates. It depends on the surface area of the plates, you know, how big the plates are, and also the distance between them. Now, what happens in a capacitor microphone or a condenser microphone, they effectively the plate, the top plate, which we vibrate with our, excite with our audio sound pressure, that's incredibly lightweight now, because it doesn't have to be connected to anything. It's not connected to a coil. It's really free to float and can be made very, very lightweight. As I speak into it, we are modulating the distance between the plates. This distance factor that you see here is being modulated by the audio. Because of that, we can put this into an electrical circuit, which is basically a preamplifier, and that electrical circuit will then amplify that signal, balance it up, and send it out as a balance line out of the XLR that's on the end of the microphone. Now, for this to happen, this is going to need power. And so some microphones will allow you to put a battery in, and they'll power from the battery. But most of the time, we actually send phantom power from the mixing desk. It's called phantom power because it's kind of hidden power, if you like. We send 48 volts, pins 2 and 3 actually. We send 48 volts on pin 2 and 48 volts on pin 3, and the microphone then picks that voltage up, and that powers up the preamplifier that's in the microphone. What is the advantage? Well, it's probably easier for me to show you that by you listening to that. Let me just say that I'm using a condenser microphone here. This is the microphone that you're hearing. It's just that I tend to have it out of shot. It's an AKG 414. It's quite an expensive microphone, really. I've got a matched pair of these, which I use for various things, and they're fantastic talk microphones. It's a large diaphragm condenser microphone. It's the sort of thing that you would use as a studio mic. If you were feeling rich, maybe you would use them as drum overheads. I personally wouldn't, because I just don't want a stand falling over with £1,000 worth of microphone on it. There are a bunch of things in the doing live sound for a band that are going to catch you out, and needing to use £1,000 microphones on drum overheads is not one of them. But let's start with a dynamic. So you're listening to a capacitor microphone, a condenser microphone at the moment. I'm going to mute it so you should hear that go away. I'm now on a dynamic microphone, a Shure Beta 57A. Obviously, it's going to sound more direct if I use it in this way. We can talk about the sound quality, but I'm going to mute it for you and go back to the studio mic. And you'll hear more room in the studio mic because it's further away from me than me using this thing handheld. Because of that, the signal to noise ratio will be better. Now, I don't mean signal to noise in the sense of the noise that comes off the microphone. I mean signal to noise in terms of my direct sound compared to the room sound. The ambience of the room is going to be more noticeable if I use the microphone that's just here out of your view right now. There'll be more ambience, and in some ways, when you're recording or doing live sound, we can think about the ambient sound, the stage sound, as a noise. So let's talk about this dynamic microphone. The advantage of it is, obviously, it's a simpler microphone than a condenser in that it needs no electronics inside it. They are very robust, and you can drop them and you're probably unlikely to break anything, and they are cheaper, but they have a limitation of frequency response and dynamic response, actually, because there's weight in the diaphragm, because the diaphragm has to be connected to a coil which has got to move in this magnetic field. The mass of that reduces the frequency response. In audio, when we make something which is heavy, that's going to have limited frequency response. It's the same reason why in a speaker you have a bass driver which will work up to certain frequencies, but when we want to go higher than those frequencies, what we have to do is we have to go to a tweeter, a high frequency driver, which is generally a smaller diaphragm, much lighter, and therefore can vibrate at a much higher frequency. So you can probably already hear with this microphone, it is compromised in its detail and frequency response. Whereas if I go to the microphone that I've got up here, you can probably hear a lot more high frequency detail. What you need to do is probably try and process out any of the kind of room ambience that you hear. Once you've got used to hearing a room ambience, you'll start to process that out in your perception, and you won't hear the room. You'll only really notice it when I mute this and go back to this microphone. Okay, so that's one of the differences. Now I can show you with a pencil condenser here. So the first we learn about a capacitor mic, a condenser mic, is if you just, you're going to get some nasty noises, because what we're doing is we're cutting the phantom power that's going to the electronics in the preamp, and that's going to give you a nasty bump. If you do that through a big PA, it's going to be really unpleasant. So don't unplug your condenser microphones. If you have a bad connection at this point here, you can get banging and popping, so that can be a reliability issue. When we're doing line checks with condenser mics, what I mean by a line check is we're testing before the band turn up to make sure that everything's working. If your channel is going to be a condenser channel, it's sometimes a good idea to actually use a condenser mic to actually line check it, rather than just sticking a dynamic on it, because it won't tell you the true reliability of your connection. So that's why we go to condensers, because they've got high frequency detail and high frequency dynamic response. So I'd be using this microphone in a band context, on hi-hats, on drum overheads, maybe an orchestral context. I'll probably be using condensers pretty much everywhere, because I want the fine detail of an acoustic instrument, maybe an acoustic guitar or a violin or a cello or a bass or a horn section. I do really want that detail. I don't necessarily need the frequency response, and I might be actually taking off some of the high frequency response off of some of those instruments, but I do want the dynamic response. I want the transient response that I can get from a condenser microphone. For vocals, and this is a Beta 58, but this vocal mic is pretty much industry standard. You'll see it everywhere. They're not the best microphones in the world. I'll show you something I've got in my box which is much nicer than this, but you don't get sacked off for using these things, and they're ideal to be used for vocals, because we don't need that super high frequency response for the vocal, because we really need something that cuts through in that kind of 3 to 5K area, which will really make a vocal sing in a full mix context. And they're robust, and handling noise is good. You can hear there's not much going on here in terms of handling noise. It's designed to be handheld, it's designed to be robust, it's designed to have a good pop shield in it, and that's the characteristics of a reasonably good dynamic mic. You would never use this microphone for vocals, okay? And there are good condenser microphones out there that absolutely are designed for vocals. The best microphone isn't always the right microphone, and just because it sounds better to you and you're getting this really zingy sound out at front of house, you might be giving your monitor engineer a real nightmare in monitors. So the best microphone actually is the one that extracts the best performance from the performer, and obviously a performer needs a good level of monitoring. The other issue we sometimes have with really high performance condenser mics is that when we start to wear in ears, because the frequency response of that mic is so high, they get really lot of stressy cymbals from maybe a drum kit or other instruments on the stage as high frequency stress in the ears. And what you start to do is you have to EQ that out on the desk, and then what we're doing is we're using a microphone that's got this fantastic frequency response, and then we're getting rid of it with EQ. Well, that's a bit counterproductive. We would have been better using a microphone that's naturally damped and is doing that without needing that kind of processing in the first place. So dynamic mics, well behaved, easy to use. Condenser mics, going to give you more accuracy, going to give you more transient response for more subtle instrumentation, and instruments with high frequency content like cymbals, overheads, hi-hats in the kind of contemporary band context. So pickup patterns. We could take a microphone and have it omnidirectional. The microphone that you're listening to here actually has got settings on it. Let me check that you can still hear me, and this is not a cacophony of mess, but I've never tried to do this before, so let's see where we get on. Can you see here that we've got pickup patterns, and at this end we've got omnidirectional, and at this end we've got figure of 8 actually, but in between we've got the cardioid responses. Now I'm talking into the back of the microphone at the moment. If I turn the microphone round, you'll see it sounds an awful lot better, because we're using a cardioid microphone, and this is talking to the back side of the microphone, and this is talking to the front side of the microphone. Now I can use this switch on this expensive 414 and make the 414 now fully omnidirectional, and so now supposedly it doesn't matter whether I'm talking from here or talking from here or talking from here, it will sound pretty much the same, and it's not bad, is it really? That's an omnidirectional microphone. Whereas if I go onto this tight cardioid setting, then there's not a lot of pickup from the back, and there's an awful lot of pickup from the front, so you can hear it's really biased to the front. So if we take a typical microphone, you know, like this Beta 58, we're going to have maximum response from where the vocalist is, and we want progressively less response as we come off axis to the microphone, to the point where there is no response at the back of the microphone. So if we trace that pattern, it will look like this. It looks like a heart shape, and that's where the word cardioid response comes from. So you can hear that there's good powerful response from the front of the microphone, and as I come away from the microphone, it's designed to have very little response from anywhere else. Tight at the front, really good pickup, and then as I come off, we have less response. The reason we want this is because of this idea again of signal to noise ratio. What the microphone is focused on, which is my voice, is the signal, and everything else in the room is noise. It's either ambient stage noise, it's the drum kit, the loud guitarist, the keyboard coming from a keyboard fill, whatever it is. It's not something that we want to be picking up on this microphone, and that's why in general we don't use omnidirectional mics for live sound. We use cardioid mics, we use directional mics for live sound, so that we get the thing we're interested in listening to, and we don't get the thing we're not interested in. Now there are different kinds of pickup patterns. The SM58, the slightly cheaper version of this, is a cardioid microphone, and this is a supercardioid or hypercardioid mic. Now the difference between cardioid and supercardioid is it's just the tightness of the pickup pattern. So a supercardioid or a hypercardioid, they're both the same thing. The sound will fall off very quickly as you come off axis. Can you see that really, if I'm off axis, I get a lot of attenuation very, very quickly. So they are very sensitive to the front and less sensitive to the side. That falls off very, very quickly. This would be less obvious on a 58. Now, I will use in general supercardioid mics mostly. There's one downside. A supercardioid mic, unfortunately, to get the tightness that we've drawn here, a supercardioid mic does have a slight lobe of pickup right at the back of the microphone. So if I go round and round, you'll hear we're decreasing in level, but then I get to here, and I think you can maybe see that there is some pickup right from the back of the microphone. And for this reason, on a hypercardioid, it's bad practice to have a monitor that's right facing up to the microphone. It would be better practice to have the monitors just slightly left and slightly right of the performer. Don't put a wedge here. Don't do that. What you want to do is put your monitors here and here, and that will be in good ear alignment for your performer. Also, you're not firing energy into the polar pickup pattern of the microphone. Therefore, you'll get better gain before feedback if you have this kind of slightly left, slightly right arrangement of monitors. If you're not using a pair of monitors, maybe that's too expensive and you've had to compromise slightly, so you've only got one monitor that you can put in. It's always really good practice to think about where the loudest sound is. Well, let's say, for example, we've got a drummer that's over here with his cymbals and his really loud snare drum that he's hitting constantly. The singer that's just to the right hand side of the drummer, the singer's right ear is being dominated by drums. It's really loud in that ear, whereas the left ear is clearer and is not being masked by the drum kit sound. Or let's imagine we've got, you know, a really loud guitarist over here. They always have their amps too loud, don't they? You are much better in this situation putting your monitor on the left hand side of the singer, as I've drawn. You'll achieve an amount of perceived monitoring that the singer will be much happier at a much lower level, maybe 6 dB down, and probably a lot lower and below your gain before threshold feedback. So you'll have a much nicer time monitoring this way. Let's talk about proximity effect. So this is what happens as you get closer and further away from a microphone. As I get further away, the thing's going to get quieter. And the reason for that is it's an inverse square law. Every time we double the distance between my mouth and this microphone, we're going to drop 6 dB of level. Can you see the diaphragm is about here? Now, if I offer up the basket, you can see that the diaphragm is about 5 millimeters above the blue line there. It's about 10 millimeters from the top of the basket. You never get to hear anything from me that's not compressed. In fact, you know, there's a rule of audio for you. Don't let your audience hear anything uncompressed, because we want to limit the dynamic range of things, and you're going to be listening over your headphones or over some speakers, or you know, God forbid, you're just playing it back on an iPad or an iPhone. I really need to reduce the dynamic range, and that's what the compressor is doing. You can see here that I'm running 3 to 6 dB of gain reduction. Compressors bypass, so I'm at 10 millimeters from the diaphragm, and I'm going to move to that level there, which is about double the distance, and that's dropped about 6 dB. So going from there to there will drop 6 dB. If I double the distance again, I'll drop another 6 dB. And if I double that distance to there, I'll drop another 6 dB. When I go from there to that kind of 20 dB distance, that really is the same as dropping the fader down 20 dB like this, you see. You know, there's 20 dB down and back up again. And that is double the distance, double it again, double it again. It's that kind of effect. The closer you get, the louder it gets. Now, it seems obvious, doesn't it? But the reason we want our performers to be on the microphone is because then we get more of this and less of the room, and that's a signal to noise issue. We don't want the room, we don't want the stage, we don't want, you know, the loud snare drum. If I back off, I'll have to pour a load of gain in to make up for that, and you'll hear a lot more room noise, won't you? You'll hear a lot more snare drum pouring down this microphone. Whereas if I go back to where we were before, where I drop the level on the fader or on the, you know, the gain, and I go back and give more acoustic gain because I have better proximity, I'm clicking my fingers and you can't hear it really. So the signal to noise ratio, signal being my vocal, noise being my fingers, it will be much better. And we want that for all of our microphones. So we want to get the mics as close as we can. Okay, in live sound, you see, we don't get the benefit of being able to record things one at a time with no other extraneous noises bleeding into the microphones. Our stage is full of bleed, so we want to minimize the bleed by, first of all, getting stage levels down if we can, and we'll talk more about that in other modules. But if we can't do that, let's at least make sure that everybody's on the money and they're touching the lips with their microphone. Okay, that will sound better when you come to mix that. The other thing that's changing is the tonality is changing of the microphone. So when I'm very close to the mic, I get quite a lot of warmth in it, to the point where you'll notice that I've EQ'd, the only EQ I've done to this microphone is just to roll some bass off. That is taking out some of the bass in this microphone. Look, obviously that would be too much, and I want some warmth in it, but not too much warmth. And some microphones have got really good bass response, so you would need to get rid of some of that bass response if somebody's using it in a very close way. Now, if I back off the microphone, obviously it gets quieter. We have changed the tonality. This has got a lot less bass content in it than the equivalent, which is where I pull this down and go closer. Can you hear that? That has got a lot more warmth and low-end tonality in it than the equivalent of backing off and increasing gain. This is a thinner sound. You have to EQ for what you want to hear. So if you believe there's too much low end in this, okay, take some of the low end out on the high pass filter that I've done there, and that's maybe in a better place now. If the performer doesn't return to this position and decides to return 3 or 4 inches away, change that quite quickly by altering the gain. But now the tonality is very, very different. So you'll then have to go and re-EQ it and then maybe put a little bit more bottom end back in. So this becomes a chasing process. So it's much better if you can encourage your vocalist to be on the microphone. It wants to be in that kind of position where there's a top lip touching the mic, because if they do that, you know that they're going to return to that every time, because it becomes a habit of feeling the microphone on the top lip. And you're going to be getting the best possible gain before feedback in that situation. You're going to be getting the best possible signal to noise ratio, and you're going to be getting consistent tonality. You're not talking about the difference between, a 2-inch, 4-inch, something back here, and you're not riding the gain up and down all the time. Now, the compressor will help you a little bit with that, but it's not going to solve the problem for you. So that's good microphone technique. And I'm not a singer, so please, forgive me if I make some horrible noises now. I'm not saying that a performer shouldn't use a mic technique which allows the voice to be stressed. So sometimes you have somebody that is singing, and then when they go for a really loud portion, what they'll do is they'll self-modulate their own volume like this, hey, hey, and then they'll go back on it. And so what they're doing in that situation is they don't want you to necessarily hear more power and more volume. They might want a little bit of that, but what they're doing is they're coming off of the microphone so that they can use more power, which then creates a different kind of harmonic distortion, if you like, a different tonal balance in their voice, a stress voice. And so they're basically controlling the level for you. There's nothing wrong with that kind of microphone technique, but what we want to encourage is a return to bass, a return to a consistent position, which will give you constant tonality and constant volume, and to allow whatever thresholds you've set to your compressors to be working correctly. Now, why do vocalists back off from microphones? It can be for a number of reasons. If you've got somebody that isn't really that confident in their own voice, if you've got them too loud in monitors, especially this is true for in-ears, if you've made a vocalist too loud in their own monitors, they'll become self-conscious of their own voice and they'll start to back themselves off. If they've got the monitor on the floor too loud, they walk up to the microphone and go, oh, that's loud, and they back off. Now you've got bad signal to noise. You're going to be trying to push the vocal louder in front of house, and you'll get into gain before feedback problems. So sometimes you need to reduce the level. You can ask the question, look, I'd love you to be on the microphone. You really have got to produce the band. You've got to get on stage with the band. You've got to get with the vocalist, put an arm around that person, say, look, I'd really like you more on the microphone if you could. I'd like it to be touching your lips. And this requires a level of musicianship. It's great if you're a performer yourself, if you played in bands. I've sang badly in bands all my life. It helps if you can get with a performer, put an arm round and encourage good microphone technique, proximity effect, a boost of warmth, good signal to noise ratio, controllable and predictable behavior with wherever you've set your compression thresholds. Okay, so that's proximity effect. And now, as promised, I'm going to go through my mic kit. So I've pulled my foamies out my flight case. You can see here that I've got 6 Beta 58s. So Let's talk about the Beta 58 microphone. Beta 58, if money, kind of all the money in the world evaporated, sound engineers would barter with these things. It's kind of the industry standard microphone. Is it the best microphone in the world? No. I prefer the Beta version because it's got a tighter cardioid pattern. Go back to section 2 where I talk about cardioid patterns if you don't know what I mean by that. But it's tighter response. It's got, compared to a 58, it's got a little bit of a presence spike in it. Sounds great. Works on vocals. You could use them pretty much for everything, really. You stick them on a tom if you're short of microphones. Wouldn't be ideal, but I like to have 6 of them because then if I've got a big vocal group, I can put 6 identical mics out. Happy days. Obviously, it's a dynamic microphone, well behaved, simple to use. It's going to behave itself in monitors, and it's going to sound reasonable in front of house. I'm not going to get into really too much A-Bing of microphones here because it's pointless. This microphone has not been tuned or developed for you to listen to through your headphones or on your iPhone or whatever in the way that you're consuming it now. The right way to listen to this microphone is through a live PA system. Live PAs carry certain kind of harmonic details compared to a studio monitor. Of course, they carry an awful lot more headroom, and our perception of sound very much changes. I mean, you're going to be listening to this at 85 dB maybe if you're keen on listening to me, whereas I'm going to be producing, you know, a band's show maybe at 98, 100 dB, and your tonal response of your ears is very different at those ranges. So don't get too hooked into what this sounds like through this kind of studio setup. Trust me, when you're listening to this through a live PA, it's a well-behaved microphone. Now, it's got a kind of a partner, which is the Beta 57. So Beta 57 has got a slightly different pickup pattern, and the actual capsule is identical, and the body of the microphone is pretty much identical, apart from the label on the front of it. It's the same mic, really. The difference really is in the basket. Firstly, the basket changes the polar response slightly. So this is a little bit tighter. It's even tighter cardioid than a Beta 58. But the other thing that it does is the basket is actually slightly closer to the front of the mic. That distance there, if you take them both apart, you'll find that the distances are just slightly closer. So because it's closer, you can get closer on the mic, and you will therefore get more gain before feedback. And some people do use these mics as vocal mics. Give it a try. If you're struggling for gain before feedback on a Beta 58, then try a Beta 57. You might find that just because you've got that slight closeness, you can see it there, look. It's closer to the diaphragm, and so you'll get more proximity level. So I always have a couple of these in my mic kit. That's one, and this is its mate, and I use them on guitar cabs. It's my go-to microphone if I'm miking up guitar cabs. Also fantastic on snare drums. I mean, they sound great on snare. I really like a Beta 57 on snare. I don't use it on snare, and I'm going to come to why I don't use it on snare. You need these mics in your kit, okay? Nobody gets sacked for putting out Beta 58s on vocals, right? Cool. You know, a Beta 58 is an okay mic, but it's not a great mic. They're 120 quid or 130 quid. Be careful when you're buying them, because there's rip-offs all over the place. If you're buying it ridiculously cheap, it's because you're buying a fake copy of a microphone. Make sure you buy your mics from a reputable source. You know, in the UK, I'm going to be biased, aren't I? But give SFL Group a call here in Reading, near London, and we'll help you out with microphones. For some of the secret microphones I'm going to tell you about, I'll give you links below. But I want to talk about this microphone. It's an MD435. Okay, so MD435, it's just really good. It's not cheap, by the way. I have a couple of these because if I want to go really special on a Vocalist, MD435. Why do I like it? So this is my Beta 58, okay? There's no EQ, it's pretty much flat out the box. Beta 58, and I'm just going to do a quick change over to my MD as best I can so you can't forget what this sounds like. And then this is the MD435. So
The frequency response here is just way better at the top end. It's so much more of a sexier microphone. Once you've listened to this for a while, and I've made no gain changes, it's, you know, I've just let that run into the compressor the same. So once you've listened to this for a while, if I go back to my Beta 58, the Beta 58 will sound a bit cheaper, because it is. What I really like about the MD435, you get from it kind of a condenser sound from a dynamic microphone. It's dynamic, it needs no phantom power. I really like the behavior of dynamics in live sound on vocals, because they're good in monitors, and it's just great, and it feels really good as well. The handling noise is good. It's all right. It's good, isn't it? I mean, you're not going to sing a song doing this, are you? Let me go to the MD435. I can't hear it. It's just really good handling noise. The other thing I noticed,
I've got my scales, and my Beta 58 weighs 283 grams, and my MD435 weighs 351 grams. It's more microphone. It's heavy, man. And of course, you know, we don't evaluate microphones based on weight, but it's just a really solidly built, beautiful microphone. So MD435s, if you want something sexier than, you know, having 6 of these in your kit, and why wouldn't you have 6 of these in your kit? You would do. But if you want something a bit sexier for special occasions and special vocals, and something where you need a little bit more top end and a little bit more delicate accuracy without having to go to a condenser mic. Remember, condensers can be a bit harsh in in-ear monitors and can give you a bit of zingy feedback on stage from stage wedges. Sennheiser MD435, it's the money. Okay, so next let's talk about drum kits. What we're going to use on bass drum, well, I'm going to use a Beta 52. It just sounds great. I mean, I stick it in the sound hole. I used to do the thing where I put one in the sound hole and I put a Beta 91, you know, the plate mic in there, and then I'd spend ages trying to make them both coherent, and it's just a waste of time. If you've got a good kick drum, put it in the sound hole, job's done. You get a big air rush impact, plenty of low end. I think we've all gone away from having so much top end in our kick drums, it kills your ears. Fantastic dynamic range, fantastic sound pressure level, capability, great tonality. Why wouldn't you? Built like a brick shithouse, as we say here in the UK. Beta 52 is what I use on kick drum. Okay, now what do I use everywhere else? Well, you know, I have to look after a band that have got 2 drum kits on live on stage, so I need 12 microphones, and my choice is E604s. Okay, Sennheiser E604. Can't go wrong with these. They're not expensive, and I use them absolutely everywhere, all over the kit. So snare top, snare bottom, and every tom. So there's 7 of these on each kit. Sennheiser also make an E904, okay, which is actually a more robust microphone, and it's more expensive. When I got my 14 of these to do my drum kits, I kind of really wanted 14 of these. They're both great microphones, by the way. They both use these really, you know, kind of cool clips that I have no problems clipping these onto toms or snares. This probably sounds a bit better, but it's more expensive, and the disadvantage of it is quite heavy. Can you see that? Because of the weight of this, you end up with these kind of moving all over the place as the toms get hit. Whereas because these are much lighter, they just don't do that. One of the disadvantages of an E604, and by the way, I'm not sponsored by Sennheiser, I'm not sponsored by Shure, I just buy these things because they're great examples of what you need to be buying to do the job. These can fail on you, and the way they fail is they don't fail in any way kind of electrically. If they get hit too many times really hard, the glue seal around here can fail, and the whole inner of the mic ends up being pushed out. So that's the only failure I've seen on this microphone, and I use them a lot and they get hit pretty hard. So E604 would still be my choice because you're going to save a bunch of money, but technically an E904 is a better microphone from Sennheiser. Snare, you know, I guess technically if you wanted to, Beta 57s on snare top and snare bottom probably would be a better choice than an E604. It's just that I don't do that because I want an easy life, and I'd much rather save 2 mic stands, which in my Genesis band is actually 4 mic stands because I've got 2 drum kits. Hi-hats and overheads. Okay, this is one of my it's not the dirtiest of secrets, but it's a pretty dirty secret. This is a Superlux mic. It's a condenser, and it's a CM-H8K. CM-H8K, link below in the list. I think I paid about £94 for these. In the kit, for your 94 quid, you get interchangeable heads, and you get a cardioid, you get an omni, and you get a super cardioid head. In fact, I've got all the heads in here, look. That's great value. And then the other thing that you get with them is really nice windshields that just pop on. It sounds great on cymbals, overheads. Fantastic for anything where you need that little bit of pencil condenser detail. I really like the fact there's no switches on it. There's no low cuts, there's no gain things. I've done quite a lot of orchestral work where you get you guys that are helping you on stage to put out 16 microphones that are all the same. And as much as you ask, can you please make sure their low pass is off, they're not set to any gain reduction? You know, invariably you'll get a couple of them go out that aren't, you know, set right, or the switches go dodgy or whatever. I just like that this is simple. It works really, really well. Okay, so this is it. And obviously at the moment it's not a vocal mic, so you wouldn't normally be using this, but I think you can hear that high frequency detail in it. It's a great Microphone. Superlux CM-H8K. No brainer. I've got something in here that I've not mentioned. I love this microphone. Beyer, it's a Beyer M88. This is a classic vintage one with the silver top. The bass response on these mics are phenomenal. You can use them on kick drum, but I wouldn't anymore because this is a ribbon microphone and you can damage the ribbon. I use this on my Phil Collins Vocalist. It's got the look, but I only ever use it for promo because he spits it out. I mean, I've got my Vocalist is quite moist, shall we say, and I'll only get halfway through the gig with this microphone before it needs drying out. So honestly, I have him on on one of these, which the MD435, which I've told you all about. I need to look after this because there ain't many of these left. The TG version of this is much more robust actually, but it doesn't look as pretty. Look at that, that looks so pretty. So now I'm going to tell you a couple of my dirty trade secrets, which are so dirty that I dare not even tell you about them, really, to be honest. So here I've got a DPA microphone. It's a DPA 4099. It's what I would use on double bass or cello. You can put them on sax as well, and you can get all sorts of clip hardware for them that DPA make. And it's a phenomenal microphone. I mean, a 4099 is a beautiful piece of kit. Let me just it's a microdot. These are really strong actually. You might think that they'd be really weak, but this would either go on an adapter that goes into a radio mic pack, and you need to get the right adapter for either a Shure microphone or a Sennheiser type pack. But in this case, I'm going to put it onto an XLR preamp adapter. And here you go, you've got a condenser microphone, which is a 4099. Boom, 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 boom. The bass response is fantastic. The quality of the microphone is awesome. Happy days. Let me show you something that you can buy a lot cheaper. So in this box, I have an Ovid C100 microphone, which is basically a rip-off of a 4099.
I didn't catch that. Could you try again?
Siri would like to know more about this microphone. So it has the Shure adapter plug on the end of it, so that you could plug it directly into a Shure radio system. But equally, if you want to hear it, I'm going to plug it into the supplied thing that comes with it. And again, these are dirt cheap. I'm going to link them below, and you're going to get them from Thomann. Now, I make no money from recommending the Thomann microphone to you, and I'm almost embarrassed to do it, but they're just bloody brilliant. And now, so I'm going to plug it in. You could put it on a violin, a viola, a cello, whatever. It's not going to have the same maximum SPL as the proper DPA microphone. So I'm not sure I would be using it on Toms. I've not tried it. I just don't think I would do it. I think one hit and it's all over. And we're back here with this mic, and so you're listening to the I'm just making sure that it is the right mic. It is the Ovid that you're listening to, and I'm just giving it a little tap here. I just would like to equate, if you like, the difference between maybe this microphone that you're hearing, and then I'm going to have a listen to the self noise. I'm not hearing much of you. It's pretty quiet, I would say. I'm just going to swap it over now. I'm back on the DPA, and okay, the handling is not really any different. I mean, it's really the same thing, isn't it? I can hear smoothness though in the low end of the DPA mic, but I don't know how much these are. The DPA is probably about, I don't know, by the time you finished, about 350, 400 quid, and this isn't. So there you go, dirty secret, Ovid C1000. If you want such a thing, it's a no-brainer. You didn't hear it here, Thomann. Okay, I'm on my Superlux now. As you know, I love these. I've got 8 of these in my kit for various things, just to have. And is it the cheapest microphone in the world? No, but these are. So this is my next guilty secret. So you spend about 90 quid, I think, for this box with 2 mics and a stereo bar and windshields. And what are these? You're only going to get a cardioid microphone, and it does have, gain switches on it for attenuation and all the rest of it. And these are T-bone mics. These are, again, from Thomann. They're SC140s. And you're paying about 45 quid each for them, and you're going to get the box of a pair of them for 90 quid. And I'm going to go to the microphone now, and there's a couple of things I really like about this and a couple of things I don't like. So they're great. You stick them out on an orchestra and they're fantastic. And if you listen to the self noise, it's pretty good. Let's just go back to the Superlux. If anything, maybe the Superlux has got a higher self noise. Now, there is a thing I don't like about it, and you can hear it. The microphone case has got a nasty resonance to it. You know, it's almost like a note, isn't it? Do you know what I'm saying? Whereas if we look at the Superlux, it's much better damped, isn't it? It's a better microphone structurally, I would say. Yeah, ding, ding, ding. It's like a bell. But that withstanding, and you're not going to hear that once it's on the stand, on a drum kit, drum overheads. Come on, people. It's cheap and cheerful. 45 quid each, 90 quid for the pair. And if you need a load of condensers that are the same on a choir, why not? I would do these all day for that kind of money. That it doesn't matter if it only lasts you a couple of years. You can throw it in the bin and buy a new one. Good dirty secret microphone.